Okay, hi there. So our goal today is to graph lines, and we want to see the big idea of a couple of easy ways of graphing lines in a chart, in an X and Y plane. So we have a couple ways of describing this relationship. We talked about a function here, and the idea of that's right, graphing lines. And I could actually spend the next about 2-3 weeks on this. I can answer that once we're done, okay? Thanks for asking though, Roberto. So graphing lines, and the idea is how do we end up graphing a line? And this line we mentioned before from our examples is a representation of a relationship. Like, imagine if this was my allowance, right? The worse I behave, the less money I get. Or this could be my free time, right? The more homework I get, the less free time I have. So this is a negative correlation. So as the x gets bigger, my y starts to decrease. And we're going to look at different examples, maybe another one where I start to increase. And as x gets bigger, my y gets bigger. Okay. So how do we come up with these equations and these graphs? We have a basic one here, and let's go and look at something called standard form. So everyone writes standard form. And in standard form, the whole idea here is that x's and y's are on the same side. X's and y's are on the same side. X plus y is equal to, let's say, 5. Okay, x and y equals to 5. So we put x's and y's on the same side, and this is what we call standard form. And one of the cool things about standard form is that we can come up with a relationship pretty quickly. Now, I want you to think of standard form as two people who are trying to balance each other out. Okay, let's say maybe this is your mom and your dad. X is your mom, and Y is your dad. Okay, and you're trying to pay for parking. Parking's $5. So if your mom has $0, let's create a table here, X and Y. If your mom has $0, how much does your dad need to pay for parking? Your dad better have $5. What if your dad had $0? How much would your mom need? She better have $5. The idea is these equations balance each other out. If I pick a high x, I might have to pick a lower y. Or if I pick a high y, I might need to pick a lower x. Imagine this was an example of you and your siblings having to share $5, right? And if you spend $5, your sibling spends nothing. If you spend nothing, your siblings can spend $5. But what if we go in between? What if your mom has $1? That means your dad has to bring up $4, and that's still $5. What if your mom has $4 and your dad has to bring up $1? So you still end up with $5. The goal is whatever combination that we have, it still has to equal to $5. Right? And if we want to graph these points, x's and y's, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We can plot these points, and you'll see a relationship of all the possibilities. So if x was 0, okay, so here's the part where I need to be able to show you guys. If x is 0, okay, x is 0, what is your y? Your y is 5. So we always start with x's, and then we climb up to our y. If x is 0, here, that's 0, and then we climb up to our y, 5. So 0, 5. So just put a dot at 5. Our next point we said here was 5, 0. So 1, 2, 3, 4, 5. And the y is 0 means you are sitting on the floor. If your hotel room is on the ground floor, that's the 0 floor. If your hotel is on the 5th floor, you got to take the elevator. So now here's the cool part. Once I have only 2 points, I can now draw a line. Now this line doesn't just stop at the 2 points, but it keeps on going forever. Okay. And try to draw the line the best as you can. You don't need a ruler if you don't have one, but if you have one, you can make it look nicer. Here's my ruler. I can make that look a little bit nicer. Whoop, didn't make that look nicer. Looks nicer. Right. And along with this, you need to remember to do one more thing with these. Draw little arrows at the end of your line to say, hey, you know what? This line doesn't just stop here. It keeps on going forever. Now, we threw up a couple more points that are in this relationship. We said 1, 4. 1, 4. Now let's count. At 1 and 4, 1, 2, 3, 4. Hey, that's on my graph already. I didn't have to put it out there because it was on that point already. Let's do 4, 1. 1, 2, 3, 4. 4, 1. Hey, that was there too. Let's look at another point that was on here. If I go 2, 2, 3, is 2, 3 a possibility for this equation here? Would 2 plus 3 equals to 5? Yeah. How about 3? Let's see what this is. This is 3, 2. Would 3 plus 2 equals to 5? Yeah. So it turns out all these relationships that are illustrated in the graph are actual solutions for this equation here. So one thing that a line really is, I'm going to go ahead and show you something kind of interesting, is that a line is actually not a line. It's actually all the little tiny dots that answer this equation. So if I put 5, 0, 0, 5, that is on my line. If I use 5, 0, yes, that's on my line. 1, 4, yep. 4, 1, yep. 2, 3, yep. 3, 2, yep. What about all the decimal points in between? What if I pick 0.5? What if your mom had 50 cents? How much would your dad need so you guys could pay for parking? He would need $4.50, wouldn't he? So at 0.5, you would need $4.50, which looks like right there. What if you had $1.50 or your mom had $1.50? That means your dad would have to have $3.50. It's this idea of this balancing. As X changes, so does Y to accommodate. And if I just, okay, here's the crazy part. I'm going to draw a bunch of little dots here, right? And if I draw these dots over and over and over again, end up with this full completed line. So I want you guys to realize that a line is really made up of all the answers, all the relationships, all the points in between these. And instead of drawing 1,000 million dots, we just draw a solid line to represent them all. And I think that line is so much easier to draw than drawing all these individual points. For this graph, I came up with 1, 2, 3, 4, 5, 6, 7, 8. That's 8 different points on this graph. Let me tell you this, you only need 2. Line graphs only need 2 points. And we're done. So let's do this one more time with another example. And we'll say 2x plus 1 is equal to, let's do 9. Okay, a little bit bigger number. Whoops, this is a y. I don't know why I did that. 2x plus y equals to 9. Again, this is what we call standard form because x's and y's are on the same side. This looks very standard to me. Okay, so here is what we're going to do. Create a quick table just as we start. And I want us to plug in, whoops, darn it, let me do one more thing. This 9 is not going to be, let's use it. Okay, so let's make our value 0. And this is the easiest way for us to start to graph in standard form. Plug in 0. Let's first make x 0. If I make x 0 plus y, what does y have to be to balance out this equation? If x was 0, 2 times 0 is 0, so isn't it kind of gone? So what does y have to be? Thank you. Y has to be 9. It has to pick up all the slack. Good job. It has to pick up all the work. And you guys have experienced this in your family, right? You guys have chores to do, and if someone doesn't do anything, you have to do everything. But it's more like if your mom or dad don't do anything, that means the kids have to do everything. Or the other way, if the kids don't do anything, the parents clean up. So this is the balancing idea. Now, what if I make y 0? If y is 0, what do you think x has to be so we can still get up to 9? 2 times what gets us back up to 9? Okay, I have an answer in the chat. Let's see. 4.5. Is 2 times 4.5 going to get us up to 9? Yeah, right? 450 times 2, that's $9. Now, this is one of the easiest ways for us to graph lines, is to look at what we call, these are called the intercepts. And this is my y-intercept, and this is my x-intercept. Now, we call these words intercept because think of the word intercept in English. If you intercept something, that means you run into, you catch up. The highway patrol has a special car called an interceptor. And what are these cars? Why do they call them interceptors? Because they're faster and they're supposed to catch you. They intercept you while you're speeding, right? In football, when the football is intercepted, someone else catches the ball. It crosses the ball first before the receiver does. So this word intercept is kind of cool. We use it in a lot of different ways. So here's the idea of the x and y intercept. The y and x axis here. The y-intercept means where does the line run into the y-axis? Where does the line run here? When does it hit here? That's the y-intercept. And if we look at the value, if x is 0, here is 0. If x is 0, what's the y value? It's going to be 9. So at least I know maybe the graph is this way, this way, this way, this way. I don't know. But at least I know 1 point. Now, when you draw a line, we said we need at least 2 points. We need to know where to start and then which direction. If you guys ever play football, you might have the ball, but you can't throw it. Do you have someone to throw it to? Right? You need 2 people to play football. I mean, you could throw it up in the air to yourself, right? That's you, yourself, and I. But when you play football, when you play soccer, when you play any sport, you always have to throw it to someone. You got to pass it to someone. And so we need 2 lines to pass our line to. And our next point is our x-intercept. So x is down here. So where on the graph do we run into the x? 1, 2, 3, 4, 5. And 4.5 is right in the middle. So once I have 2 points, you can just draw your line. Oops, I missed that one. Does your line have to be the most perfect thing in the world? No. If you want to go get a ruler, go get your ID card, go get any straight edge, and that will make that line look 1,000% better. You see, mine looks a little crooked here. But you know, in a Simpsons way, it doesn't look bad. Now, the thing is that every other answer I put here in my table is just going to be points on this line. So one of the things in IXL today, you're going to be asked to find the x and y intercept. So we're going to easily plug in a 0. But here's where kids get confused. They forget which 0 goes where for which intercept. So when I ask you for a y-intercept, you want to make x go away. It's almost like you don't want to listen to your parents. Mom, I'm angry at you. Just go away. You're my 0. Okay, so I'm daddy's little girl. Okay? Or if you're angry with your dad, right? You go to your mom. Right? I'm was it mom's favorite son? I don't know. Okay, but you block off the one you don't want to hear from. So if I say y-intercept, I block off the x because I don't want to hear from it. If I'm looking for x-intercepts, I block off the y's. I block off the y's because I don't want to hear from it. Okay, so let's make this problem harder now. Standard form again. And when I say standard form, x and y are on the same side. If I say 3x plus 2y equals to 12. Now this one looks like it might be harder, right? Looks like it might be harder. So I'm going to do my x and y table right now, just so I have some organization. Once you guys get good at this, you won't need it anymore. But I'm going to ask you guys for my x-intercept and your y-intercept. So I reverse the order here, so be careful. I reverse the order. So I want us to plug in the 0 first. If I say x-intercept, who do I want to block off? Who do I not want to hear from? If I say x-intercept, I don't want to hear from the, thank you, the y's, the other guy. So I want to put a 0 for the y. That's my x-intercept. So when I plug in, if y is 0 now, 2 times 0 is equal to 12. Man, that means x has to pick up all the slack. But x doesn't have to be 12. What does x have to be to make 12? 3 times what is 12? Thank you. 3 times 4. And hopefully that makes sense. But I'm going to do this in the algebraic way now. So 3 times x has to be 4. X is not 12. 12 is my final answer. 4 is what I need to use to get 12. Okay? Now, I'm going to show you guys a different way to solve this now. If I write 3x plus, okay, we said we want the x-intercept. That means y is 0. So we just do the math from here. So 3x plus 0, I'm not going to write that anymore because that goes away, is equal to 12. And this takes us back to literally like our third day of class. And what I want you guys to realize is that algebra is building on itself. We're building steps and we're using tools that we learned from before. And this is solving equations. And we're going to balance opposite operations. And x is 4. So sure, you could have just said 3 times 4 is 12. And that is amazing of you. Okay, you can do that. That is excellent. And I still need you to be able to write this out, showing all the steps. Because as problems get more difficult, we want to be good at these basic steps, ways of solving it. Okay, let's go the other way. If I want to solve for a y-intercept, who do I want to be quiet? If I want to only hear from y, I'm going to mute all the x's. So what's your y value? Thank you. So let's rewrite this quickly. 3 times 0 plus 2y's equals to 12. Okay. Now again, let's use this as your mom and dad paying for parking. If your mom has no money, your dad has to make up the excess. So 2 times what is 12? 2 times 6. Again, this is mental math, right? Thank you. So I'm going to write this out. 3 times 0 plus 2y equals to 12. I'm just writing this out here so we can actually do the algebra process. 3 times 0 is nothing. So we have 2y equals to 12. And man, this is a one-step equation. Okay. So y is 6. So now here is the part that kids mess up. They say x and y is, if x is 1, 2, 3, 4, y is 1, 2, 3, 4, 5, 6. That means this is my answer, 4, 6, because we always see an x and y, and turns out, no. This point has nothing to do with the line. Because the point for this guy here, what y value do we use when x is 4? When x is 4, your y value is 0. Thank you. When your y value was 6, our x value was 0. Not 4, 6. If I use 4, 6 in the equation, let's try it. 3 times 4 plus 2 times 6. Is this 12? Well, this is 12 and this is 12. This is not 12. That's 24. This is not right. So please don't get confused and start mixing these x's and y's, these intercepts together, because they are actually two separate points. And the cool part, as being two separate points, let's plot them. My x-intercept, x's and y's. So the point in which the line runs into the x-axis is 4. That's my x-intercept. The point at which the graph runs into my y-axis, that's 6. And again, if you want to look at the point, that's 4, 0. And this is 0, 6. So okay, when I say x-intercept, I want y to be 0. When I'm looking for my y-intercept, I want x to be 0. I want to cut off the other guy. And since we have 2 points, we can now graph it. And the cool thing is that all these points along the way are actually answers to this equation. Okay, they're actually answers to this equation. Now, I want to pick a value here. If I pick 3, let's see, it looks like it would be 3. 3, 3. Oops, sorry, that's a 2. That's a 2. 2, 3. That's a point. I'm hoping that's going to work. That looks like a point on my graph. 2, 3. And let's see if that works. Got a little space here. I'm going to do a little space here, okay? If I say x is 2 and y is 3, would that be an answer for my equation? 3 times 2 plus 2 times 3 equals to 12, right? Where this is my x and this is my y value. 3 times 2 is 6. 2 times 3 is 6. Ooh, is this equation balanced? Is this a true statement? Yeah. So all these points along the way, right? All these points along the way are actual answers to my relationship. 3x plus 2y is equal to 12, which is kind of cool, I think. I don't need to know what they are exactly, but any value along the way would be a true answer. Now, let's go ahead and let's see if I can, we'll do it next time. Okay. So let's go ahead and, so on your IXL today, you're going to be doing 2 things. You're going to be answering the question, what is the x-intercept? That's it. Good question. Did I guess 2, 3? No, I actually looked at the graph and I said, hey, if x is 2, and I just walked my way up. I said, no, what? That looks like 3, right? If x is 2, y is 3. So that's my x and y value. If I want to use 1, I can use 1, and this is going to be a decimal here. But if I use 1, it would be some decimal like 4 something. Okay. And if I use 3, it would be looks like a fraction answer here. It's not necessarily perfect because most values in the line are decimals. Only when we are very careful do we get these nice whole numbers. Okay. All right. So in your IXL, they'll say this, 5x plus 2y is equal to, let's say 20. And they'll ask, what is my x-intercept? So remember, we talked about this. If I'm looking for my x-intercept, I want who to be 0. Okay, on the graph, the x-intercept is someplace on this line. It's on the first floor. It's sitting on the ground. So your y is 0. So an x-intercept, that means y equals to 0. Let's go ahead and plug in y is 0. 5x plus 2 times 0 equals to 20. So 5x is equal to 20 because the 0 goes away. So x has to be 4. And just put a big fat dot there. Okay. Now, I would like to show you the fastest way ever to do this. All right. Ready for this, guys? You don't have to write all this up. This is great. This is what you're supposed to do. And you're going to do this all in your head. This is what you do. If I look for my x-intercept, what goes to 0? The y, right? Can you guys all take your finger and cover up? Take your finger and cover up 2y. Everyone, please don't think this is stupid, but take your finger and cover up 2y and just cover it up. Don't you just have 5x equals to 20? What does x have to be? 4, right? 5 times 4 is 20. That's how fast you could do this problem. I'm not kidding. Like, if you look at my screen, if you look at I'm not sure you can see, oh, darn it. Like, to find intercepts, sure, you can see that. Yeah. So just put your finger on your paper, just cover it up, like no joke. And you just see 5x equals to 20. 5 times what is 20? 5 times 4. Okay. The IXL may then ask you, hey, what is your y-intercept? Y is equal to, okay, what's your y value? And you can do that same trick. Use your finger and actually put it on your paper and cover up the x value. Because remember, we don't want to hear from him. You should see 2y equals to 20. 2 times what is 20? 2 times, come on, 2 times 10. We know our y-intercept is automatically 10. So you can make these problems pretty quick as long as you kind of know the tricks of what we're doing. If I want to assign someone, that's going to be a 0. Right? That was going to be gone anyway because it was a 0. So we really are left with 5x equals to 20. X has to be 4 if I divide both sides by 5. Whoops, I did this again. What am I doing? I'm sorry. I put the 0 on the wrong side. If we are looking for the y-intercept, we want x to be 0. Sorry about that. When I was doing that math. So divide by 2, y is equal to 10. Right? Okay. All right. So now we have one more section to talk about. And it can be confusing because, again, we're dealing with the letters, simple letters x and y, and here is our next section. It's called horizontal or vertical. I'm not going to say the word and because it's one or the other. Is it going to be a horizontal or vertical line? So if I write x is equal to 3 and I ask you graph this. Okay. Actually, you know what? Whoops, I put on the wrong side. Change it to y equals to 3 and I say graph this. Or I say x is equal to 3 and I say graph this. But we just saw that lines always have an x and a y, right? Look up here. Didn't all our examples here have x and y? X and y? X and y? Yeah. But we have special lines here. Vertical and horizontal lines only have one voice. They only have one voice. So let's look at our left section here. And we'll make a decision, is this horizontal and vertical? So let's draw a graph. And you tell me what's the only thing you know about this? What's the only thing you know about this line graph? That y is equal to 1, 2, 3. Y is 3. At x is 1, y is 3. When x is 2, y is 3. When x is 3, y is 3. When x is negative 1, y is 3. When x is negative 2, y is 3. Can we just understand that I'm just 3? that y is 3. When you see y is 3, you draw a line at y is 3. But does this look horizontal or vertical? Does this look horizontal or vertical? This is horizontal. So it's really the opposite of what we think it is. We think y's are vertical. Yes, you're right. I'm going to climb up the stairs to the 3rd floor, but my room is on the 3rd floor. Yep, Paulo, you can think of it that way, okay? Because they gave you a y value. So please remember this, okay? If you see y is 3, folks, if I say y is 3, is this what you're going to do? 1, 2, 3. Y is 3. Wasn't that an x value? And kids honestly will mess this up repeatedly. But if I say y is 3, come on. Y is 1, 2, 3. I climbed up onto the 3rd floor. That means I'm stuck up here. That's a horizontal. Okay? If anyone ever lived in an apartment building and you walked up to your floor, the 3rd, 4th, 5th floor, you're not leaving from there. You're stuck up there. Okay? So vertical lines are the other way. X is 3. X is 1, 2, 3. We all believe, hopefully, that you see that X is 3. Fine. X is 3 at 0. How about when Y is 1? Well, X is still 3. How about when Y is 2? Well, X is still 3. When Y is 3, X is still 3. And X is always going to be 3. There is no change. It's what we call constant. So this is a vertical line. This is a horizontal line. Oops, let me spell that one. Okay, so if you can snap this into your brain, you're in a great place. Hopefully it makes sense, and this is going to be super easy for you. If we have vertical and horizontal lines, think about the floors. If it looks horizontal, you're on the 3rd floor. That's your y value up or y value down. If it's a vertical line, that's you moving left and right. That's x value. So let me give you guys, let's go backwards. I'm going to draw you 2 equations here, 2 different line graphs, and you tell me which one's which. Okay, let's take a look at the blue graph first. Is the blue graph horizontal or vertical? I want you guys to think about that over. Horizontal or vertical? Sometimes to figure out the words, horizontal, you think of the word horizon, right? That's flat. Vertical, what if you fall vertically? You fall up to down. That's vertical. Okay. In a roller coaster, you go vertical. So this is horizontal. That's a horizontal line. And also, what is the equation of this horizontal line? Well, let's count it. Y is 1, 2, 3, 4, 5. Y is equal to 5 because that's my y value. That's not an x value. Thank you. So I would say y is equal to 5. And that's the whole equation of this line. But isn't x 1, 2, 3, 4, 5? The point is, I don't care because y will always be 5. Let's look at this red line now. Red line is, well, if blue's horizontal, then y is vertical. A vertical line. And what's the y value? Well, y could be anything you want, but the x has to be x is equal to negative 3. Negative 1, negative 2, negative 3. And this is our equation of saying a vertical line. Now, hopefully this makes sense. I would go ahead to iExcel and practice a couple of these. Number function. And today's homework, you guys are going to work on 18, 19, 20, and K8H. So I'm going to tell you how hard this IXL problem is, okay? I'm going to tell you how hard it is. It says y is equal to 2. Okay, y is 2. Y is 2. Would that be horizontal or vertical? What do you guys think? Y is 2. X or Y? If Y is 2, you climbed up onto the second floor. That is horizontal. Thank you. That's it. I'm already at 10 points. Write the equation of this line. Okay, careful. What's your equation? Is this an X or Y value? Right? Since it's vertical line, we always choose the other guy. So this is X. And what's your X value? X is equal to X equals to -5. X is -5. Oops. What? What? Oh, -6. Oh, shoot. Look. Dang it. Hey, what in the world? That looked like a 5 to me. But it's just because I wasn't counting. I wasn't being careful. Gosh. You guys all see that's a 6? Mr. Ko, come on. Okay, this we said X. Okay, X is -6. That's a vertical line. Okay, I'm careful now. That's 3. So X equals to, look, 2 between 2 and 4 is 3. This is a Y value. See, Y is 40. See, you can blaze through this. I'm already on smart score 72. I've just done like 3 right answers, but because I messed up on one, right? And then this is Y. Okay, Y is, that's horizontal then. And then I am almost there. Just one more. This is X is 50. Take a look again. Why I write it? X equals to 50. Come on. Woo! Oh, darn it. One more. I need one more. Oh, Y is equal to 1. Y is, okay, up 1 space. That's horizontal. Okay, you can blow through this super fast. But we need to practice this because I don't want you guys making these simple mistakes on just you being slightly confused. You forgetting which is which, horizontal and vertical. Okay, so that's it for the day. Hopefully you found this educational. Yeah? So let me know if you guys need anything, okay?